Here we are going to demonstrate how to run Simnovus ORU-SIM with mPlane. Set mPlane support field to enable. Set DHCP support field in mPlane. Specify band, bandwidth, RCN, and antennas depending on the RAN configuration. Provide front-haul configurations. Specify IMSI, K, OP or OPC and authentication parameters and other UE information. Configure the data type and specify duration. Save the configuration and start the test case. ORU is started and DHCP server has assigned IP for the mPlane interface at ORU. Open the namespace where mPlane is running. DHCP server has allocated IPv4 address to the mPlane interface. Start netconf client from the ODU and initiate call home. IP address allocated to the mPlane interface and call home status is logged in the mPlane log. Enter the credentials to connect to netconf server. Call home is successful and netconf connection got established using password-based authentication. After establishing connection, netconf server and client exchanges their capabilities. ODU sends ORU delay management configurations to ORU. ORU received ORU delay management configurations using Edit RPC. It received adaptive delay and transport delay configurations. Bandwidth is configured as 100 MHz and subcarrier spacing is 30 kHz. Next, ODU sends processing element to ORU, which has the source and destination MAC address information for front-haul communication. For activating the carrier with the required cell configuration, ODU sends user plane configurations to ORU. There are 2 low-level TX links and 4 low-level RX links for each endpoint. Low-level TX endpoint 0 is configured with static block floating point compression. 193 as frame structure, subcarrier spacing 30 kHz. Number of PRB is 273 and extended antenna carrier configuration with extended antenna carrier ID is 0. Low-level TX endpoint 1 is configured with extended antenna carrier ID 1. Low-level RX endpoint 0 is for normal uplink transmission and configured with extended antenna carrier ID 0. Low-level RxN.1 is for normal uplink transmission and configured with extended antenna carrier ID 1. Low-level RxN.2 is for uplink RACH transmission and configured with extended antenna carrier ID 2. Low-level RxN.3 is for uplink RACH transmission and configured with extended antenna carrier ID 3. Next, there are TX array carriers corresponding to each antenna. TX array carrier 0 configured with channel bandwidth 100 MHz, antenna gain set to 80 dB, carrier active state set to active. Similarly, TX array carrier 1 for second antenna, RX array carrier 0 for first uplink antenna, and RX array carrier 1 for second uplink antenna. Carrier active state is logged for each antenna carrier. Once carrier state is active, we can verify the statistics of ORU and UE on the GUI. Verify that all the 13 UEs are NAS registered, RRC connected. Cell statistics show uplink and downlink throughput. Check the front haul throughput. Verify the counters and KPIs of RU. U-plane, C-plane, packets, section type. Check UE stats for all 16 UEs individually, IP address, UL and DL bitrate and other signaling parameters RSRP, SNR, MCS. Verify RRC and NAS messages and message counters for all UEs. This demonstration showcases the seamless configuration and management of the Simnovus ORU-SIM via the M-plane, effectively validating the dynamic management capabilities of the ORU controller.